This presentation is regarding cloud computing, which is presented by Jayavardhan, Saidas Purapati, and Ratnakar. Contents of presentation, which deals with part 1, introduction, which deals with what is cloud computing and the different types of other computings and differences between these computings. And part 2 deals with evolution of cloud computing. And the part 3 will be describing about the specifications of the cloud computing. And the part 4 deals with the advantages of cloud computing over the other. What is cloud computing? It is a kind of internet-based computing where shared resources and information are provided to computers and other devices on demand. Not to be confused with grid computing and utility computing. Grid computing is nothing but a group of computers that work together to complete a task. And the utility computing is a service provisioning model in which a service provider makes computing resources and infrastructure management available to the customers as needed and charges them for the specific usage rather than a flat rate. And autonomic computing. Autonomic computing is nothing but the different computers that manage itself and then restricts others in performing a task. Cloud versus grid computing. Both have some similarities and differences. The similarities are multi-tenancy and multitasking. And grid computing consists of data grid and computational grid, which are not part of the cloud computing architecture. What is a data grid? A data grid is an architecture or a set of services that gives individual or group of users the ability to access, modify, and transfer extremely large amount of geographical distributed data for the research purposes. And computational grid. What exactly is a computational grid? A computational grid is a loose network of computers linked to perform grid computing. In a computational grid, a large computational task is divided up among individual machines which run calculations in parallel and then return results to an original computer. Cloud versus grid. As we all know, clouds and grids are distinct. What are in clouds? In clouds, full private clusters is provisionized. Individual user can only get access to a tiny fraction of the total resource pool. User don't require any support from other sources from connecting to cloud except client interface. Cloud is transparent and easily manageable and accessible, whereas grid doesn't. And grid, what is in grid? Grid is built so that the individual user can get most, if not all, of the resources in a single request. Middleware approach takes federation as a first principle. What is a middleware approach? It is nothing but it is as similar as peer-to-peer connection. Cloud versus utility computing. Utility computing relates to a business model in which application infrastructure resources like hardware or software are delivered to the client. While cloud computing relates to the way we design, build, deploy, and run applications that operate in an virtualized environment, sharing resources and boosting the ability to dynamically grow and shrink and self-heal.
Let's talk about the cloud computing perspective, where we will be covering history, properties, components, and some examples of commercial cloud. Roots tracked back to application service providers in 1990s. Cloud is a parallel to the software as a service. Cloud is evolved from the utility computing and is a broader concept. Ever since the cloud computing evolution started, there are huge changes in technology, which has made a faster accessibility to applications hosted on cloud. One of the first milestones in cloud computing history was the arrival of Salesforce.com in 1999, which pioneered the concept of delivering enterprise applications via a simple website. The services firm paved the way for both specialists and mainstream softwares to deliver applications over the internet. Cloud computing has evolved through a number of phases which include grid and utility computing, application service provisions, and software as a service. The next development of Amazon Web Services in 2002, which provided a suite of cloud-based services including storage, computing, and even human intelligence to the Amazon Mechanical Turk. Then in 2006, Amazon launched its Elastic Computing Cloud as a commercial web service that allows the small companies and individuals to rent computers on which to run their own computer applications. As a cloud computing extends its reach beyond a handful of early adopters, Google Doc users, we can only begin in imagine its the scope and reach. Pretty much anything can be delivered from the cloud. Cloud computing properties. Dynamic provision of service resource pools in a coordinated fashion. Cloud system automatically controls and optimizes the resource use by leveraging a metering capability at some level of abstraction, appropriate to the type of services, such as storage, processing, bandwidth, and active user accounts. The resource usage can be monitored, controlled, and reported, providing a transparency for both the provider and consumer of utilizer service. On-demand computing. A consumer can unilaterally provision computing capabilities, such as server time and network storage, as needed automatically without requiring a human interaction with each service provider. Location of resource is irrelevant. User doesn't require to know about the location of the servers, where he would like to host his application, and there is no need of network latency issues. Application runs somewhere on the cloud. Web applications fulfill the end of the user. Users can deploy their applications anywhere on the cloud by using a cloud services. This helps the user to fulfill their needs in deploying their applications. However, for application developers and IT, the cloud allows to develop and deploy and run their application that can easily grow the capable capacities, which are nothing but just scalability, and work faster and provides a higher performance for their applications. And cloud offers a good reliability without the concern of a nature and the location of underlying infrastructure. It allows the user to activate and deactivate their resources. And the main advantage of the one of the cloud is like it can dynamically update the infrastructure elements without affecting the business and the runtime application. Let's have a broader look into the cloud center. A cloud computing is connected with a wide variety of devices such as tablets, phones, laptops, servers, and desktops. A cloud is divided into three phases. The first is the application phase layer, and the platform layer and infrastructure layer. In an application layer, we are using a monitoring of applications, and we can even deploy the web applications, and we can even collaborate with the applications with some other applications, and we can do chatting, and we can also even work with financial applications. Whereas a platform layer gives a services such as object storage, and it maintains the identity of the individual user and maintains a queue and databases. Infrastructure provides a storage network to the internet. It computes your application for faster to perform. The three main components of cloud computing are IaaS, PaaS, SaaS. IaaS, Infrastructure as a Service. This is the base layer of the cloud stack. It serves as a foundation for the other two layers for their execution. The keyword behind this stack is virtualization. The whole cloud infrastructure via services, routers, hardware-based load balancing, firewalls, storage, and other networks equipments are provided by the IaaS provider. The customers buy these resources as a service on need basis. The next service is a platform as a service. You now no need to invest a millions of dollars to get the deployment foundation ready for your developers. The PaaS providers will deliver the platform on web, and it is most of the cases you can consume the platform using your browser. That is, you no need to download any software. It has definitely empowered small and mid-sized companies or even individual developers to launch their own SaaS, leveraging the power of these platform providers without any initial investment. The PaaS layers includes a cloud OS and cloud middleware PaaS. For example, a Cloud App Engine and Windows Azure are the best examples of the cloud OS. SaaS, Software as a Service. This is the topmost layer of the cloud computing stack, directly consumed by end user. That is, software as a service. On-premises applications are quite expensive, affordable only by the big enterprises. Small and mid-sized businesses can afford these best software solution for their development platform or skilled manpower. The requirement of a SaaS is a computer with a browser, which is a quite basic. SaaS is a recurring based model delivered to the customers on demand. Customers can pay as you use. As per their usage, they can pay for the cloud and they can utilize the cloud services on demand. Software as a service, which has best examples are Salesforce, CRM, Google Apps, and other network providers, big industries. The main commercial cloud providers are Rackspace, Microsoft Azure, Amazon Web Services, Citrix, VMware, and many other companies. Specs. Here I will be talking about cloud specifications such as anatomy, layers, architectures, and different types of clouds, private, public, hybrid, and community clouds. The anatomy of a cloud service model includes application services, which are nothing but a Gmail, Google Calendar, and Office 365, the virtual desktops, and IBM Lotus Live, and the platform services, which are the middleware services which are used to integrate messaging and connectivity. These platform services helps the applications to run and connect to the database, and they can be a web servers which are used for deployment and development tools. And the last is an infrastructure service, which is an IBM Bluehouse and VMware, Amazon EC2, and Microsoft Azure platform, which provides infrastructure resources like a hardware and processors like that. This diagram shows the different layers of the cloud services. Here we will have a higher level view of cloud layers. And the cloud layers are segregated into three different phases. And the topmost, which allows the individuals, corporations, and non-commercial users to connect to the cloud services. And the second phase, which is a cloud middle layer, which provides a provisioning to the storage system and operating systems and network and service that are related to the apps and SLA, which monitor and securities and billing payment systems. And the third layer, which is the resources, where all the services are provided like storage and network and operating system, and all these are nothing but the infrastructures. Here we will have a look at the cloud architecture, where the user gets connected to the cloud service, and the cloud service internally connects to the cloud platform to store the user data and provide the cloud service storages, which is nothing but the SQL Azure in sense of Microsoft Cloud. and the cloud infrastructure is connected to the cloud service, which provides a space in order to deploy the applications, and moreover they provide a virtual desktops for the cloud to run the cloud services. Let's take a look at various cloud types: public cloud, community cloud, private cloud, and hybrid cloud. These cloud types are also known as cloud deployment models. These cloud types are defined by those who use the cloud. It's not defined by technology or the cost or even the location of the hardwares. When we think about various examples, we consider storing data and computing power or processing power. Before we get into the specifics of the cloud types, let's talk about NIST. What is NIST? NIST is a National Institute of Standard and Technology which has published 800-145 regarding cloud computing. The four different types of cloud: public, community, private, and hybrid clouds. Public cloud available for individual users to deploy their applications, and private for the enterprises and it is internal to the organization. And hybrid clouds, it's a combination of private and public cloud. And the new cloud is a community cloud where individual organizations or any group of organizations can opt for a community cloud. Now I'm going to start about a public cloud because I think it's a more logical space to start. Now the public cloud is used by anyone and everyone. It is used by public, it could be for individuals and it could be for companies. Anyone who wants to use it can. Those public cloud providers offer free and paid models. These might provide a storage and they might provide a computing and processing and maybe both. An example that comes to my mind is Dropbox. Dropbox offers a paid and a free service where you can store your data. Now the biggest concern is security. Is my data secured when it is in public cloud? Do I know where is my data? My concern about the hacker is getting into these. I don't know where my data is and anything those servers and even the location. Community clouds are a little bit different. These are for exclusive use by a group of users. This is for the users who share a common mission and regulatory requirements for compliance that need to follow. Example of these might be healthcare, financial, law or legal, education and energy. List goes on and on. With the private clouds, we have a private and dedicated resources. What I mean by dedicated resources? I mean private or dedicated computing and or storage. It is possible for me to have information stored in the cloud and that the storage is designated just for me and no one else have an access to the private cloud. I have the solo right to that the processing or the storage. One of the things that I got wrong when I was understanding the private clouds, I assumed that they have to be on company premises. I assumed that they have to be local, that they have to be in-house, and that's not the case. Private clouds don't have to be in the same location. For example, I could have a dedicated servers in the other states. That's still private cloud. No one else able to access those servers. The top concerns of private cloud would be the reliability and management. But the reliability we are thinking about uptime. If the private cloud is someone else's premises, I am concerned about have uptime. Do they have the proper power in place? Do they have the generators and other means of keeping my servers up and running? I don't have any control over there if they are outside my premises. Even if they are on premises, I am concerned about servers failing. Management of a private cloud requires a frequent skill set to be clear, greater skill set. They need to be able to understand how these servers are configured, set up, allocated, working together. What kind of redundancy is in place? I am able to virtualize machines too and need to understand how the storage works. The last part of the cloud type is a hybrid cloud. In the hybrid cloud, we are combining a different clouds, typically public cloud and private cloud, both in the same company. They often leverage multiple providers, but they don't have to. For example, we could have a cloud provider who offers a shared storage in a public cloud, but then also provides a dedicated computing, and that would be private cloud.
Why cloud computing? Cloud computing was introduced to overcome the problem of data centers, namely over-provisioning, insufficient capacity planning and sizing, and improper understanding of scalability. Now let's discuss about the benefits of cloud computing. Benefits of cloud computing: agility, reliability, multi-tenancy, service-oriented, virtualized, and data. Cloud computing provides agility in providing on-demand computing infrastructure in time to time, reliability in terms of self-healing, that is, to provide backup, SLA driven, it provides secure layer architecture, and it also provides multi-tenancy, which means multiple users can share infrastructure without compromising privacy and security. It also is service oriented, that means one service failure doesn't disrupt other services. It's also virtualized, which means multiple applications can run in one computer. It is also cost efficient. Cloud computing is simple in terms of transparency, scalability, and security. It's extensible with the upcoming requirements. New application classes can be accommodated easily. It's commodity based, must leverage the open source software. It's easy to install and maintain.
Let's have a look at some of the contemporary examples of cloud. Open source cloud ecosystem tools. A right scale, a startup company focused on providing a client tools as a SAS hosted in AWS Amazon services. It uses a REST interface. Canonical is also one of the company which uses a Ubuntu 9.10 Ceramic 12 for cloud services. Cloud is open for innovations. User can create a new kind of applications using the cloud services. Cloud computing open issues. Governance, security, privacy and control. SLA guarantees the cloud security. Ownerships and control can be governed by the cloud system. Reliability. Cloud is reliable where the service provider will give you a 99.99% availability of the cloud service. Cloud is independent. Cloud can be accessible by the public and private clouds. And cloud data is secure. It is a redundant cloud which keeps multiple instances where you can get back your data. And it is more cost effective and is simple to use. Cloud provides many different tools to access the services. And the cloud data is more sensitive, and the user businesses can control their sensitive data via different services. Big industries and small industries can able to access the cloud by the cloud interface, and they can able to scale their and according to their cost effectiveness.
Thank you.